Solving equations. This is basically taking polynomials, and in the last chapter they were called polynomial expressions. So the difference between an expression and an equation is an expression looks like this, and an equation looks like this. What's the difference? Yeah.
I was kind of hoping more people were going to put their hands up. I'm going to take a guess and just say, come on, kid. The X is in a different spot. Yeah, that's it.
That is not quite it.
It has the answer to the question.
It has the answer, i.e., it has a
Equation.
equal sign. That is it. An expression doesn't have an equal sign.
Oh,
An equation will have an equal sign.
I didn't see that.
All right. So when you have an equation, so now we're going to take all the rules we learned up here. Eventually, we're going to start with the basic ones and then apply them to equations. So what's the whole goal when I give you an equation like that? What's the whole purpose of this algebra stuff that we do? You don't know? Figure out your variable. That's it. The goal is to find the value of, in this case, x, but I will just say variable, because the letters will change. The whole goal is to figure out what that variable is. Or sometimes they say isolate the variable. Okay, so in algebra, they talk about inverse operations. All an inverse means, in this case, is the opposite. Okay, so 4 basic operations: addition, subtraction, multiplication, and division. What is the opposite of subtraction? Addition. And the opposite of addition is? Oh, superstars. The opposite or the inverse of multiplication would be? Division. And division would be multiplication. Okay. So we did a few of these at the beginning of this course. X plus 6. We're going to start with the most basic ones and we're going to build our way up over the next week or two. So x plus 6. I need to get rid of the positive 6 because I'm trying to get x by itself. Cade McEwen. So how do I get rid of positive 6? What's the inverse or the opposite of positive 6? Negative 6.
Oh, yeah. Yes.
And what you do to one side, you
To the other.
must do to the other side.
Always.
So 6 and negative 6 give you 0. What's 18 minus 6? 12. Now, what are you doing? All right. What should you do? Now, for these ones, it's not as important because you can kind of see the answer. But when we get into more complex ones, what should you do every time you've finished or you've solved for the variable? Sorry? Oh, yeah, like plug it back in. Is that what you said at the beginning? Yes. So sub it back in to check your answer. So this is the check. 12 plus 6 is equal to 18. and you get 18 is equal to 18, so you know you're good. Okay? Now for these ones, you can kind of just see what the answer is, right? But we're going to get into ones that are more complex. All right. 5 plus x is equal to 19. How do I get rid of the 5? Sorry? Yeah, you weren't talking. What do I do? Well, what do we do? How do I get rid of the 5 here? You subtract 5. What's 19 minus 5? 14. Does it matter if the x's are on the other side of the equation? Do the exact same thing. So how do I get rid of 22?
Minus it.
So I get 8 is equal to x. And then let's skip to this one here.
Okay.
14 minus x is equal to 5. What's the difference between this and all the other ones?
You're minus.
The x has a negative on it.
Yeah.
Is that what you're going to say? So what do I move? Because I want to solve for x. I don't want to solve for negative x. So how do I make the x positive? Oh, I see what you're doing. Okay. So there's two ways to do this one. You can either move the 14 over. Is that what you did? What did you do?
I solved it like you did, almost like you do it like the way we did the other questions, and with the negative x equals -9, and then I divided each one by -1, which
Yeah. So, but your first move was to take away 14.
yes.
Okay, that's what I was asking. So the first one way to do it is to go minus 14 minus 14, and you get negative x is equal to -9. And then because I don't want negative x, you divide the -1 off or multiply it, however you want to look at it, and you get x is equal to 9. The other way to do it is to move the x first. So if you go plus x, 14 is equal to 5 plus x. And then you subtract the 5. So I get 9 is equal to x. You get the same thing. It doesn't matter how you do it. Although sometimes it's easier to move the x's first to get them all positive, because later on there'll be multiple x's in the equation or multiple variables in the equation. So I would like everybody to solve those two, the bottom last two there, please. Leftover nachos from last night. Go.
Are these alright? Because there's no key for it.
There's a key for that, isn't
Not well, everything else, but just not this, like these questions specifically.
it? Okay, one second. There's the answers, people. Just wait till I finish this. Oh, sorry. There you go.
No, what other classes do you have?
Woodwork.
Woodwork,
Yeah.
what?
Woodwork.
You only take 2 classes a semester?
The rest are online.
Huh?
The rest are online for
You
this
can do that?
Done.
No, the rest are online. Next semester,
Okay. Are there any questions about the front page? Okay.
What does this do?
Well, we're doing it right now. Are we clear about the front page? Any questions about the front page? Okay. Flip to the back page then. All right. Multiplication, division. So we've already talked about the inverse stuff, but what I want you to remember over here is that this A divided by B is the same as A over B. Those mean the exact same thing.
Yes.
Okay. So this first one, 3 times x is equal to 6. What's the opposite? How do I get rid of the 3? That's, I guess, the better way to say it.
-3.
No. Because this says 3 multiplied by x. So what's the opposite of multiplying? Dividing. So we're dividing both sides by 3. 3 over 3 is just 1. If you're left with x, 6 divided by 3 is 2. All right, let's do this one here. 0.5x is equal to 1. What do I have to do to get rid of the 0.5? 1 divided by 0.5 is 2. Does anybody know why it's 2? Other than I just punched it in my calculator. Or, Keegan, what were you going to say?
I was going to say multiply 0.5 by 2.
Oh, that's the other way. Or 0.5 is actually a half, right? And how do you divide fractions? You flip the bottom one and multiply, right? So it's 1 times 2 over 1, which is 2. Okay? That's why when you divide by a fraction, a proper fraction, the number actually gets bigger. All right. X divided by 4 equals 3. So what's the opposite of dividing? Multiplication. So what am I multiplying by? 4, because my whole goal is to isolate the x. So you multiply both sides by 4 and end up with x is equal to 12. This one. 15 is equal to 3x over 7. What do I need to do here? Sorry? There's no addition, so you can't be subtracting. There's only division and multiplication. So how do I get rid of the 7? Why is it multiplication and not subtraction or anything else? Sorry? Because we're dividing. We're dividing by 7. So you do the opposite, which is multiplying. But what you do to one side, you do the other side. 70, so that's 105 is equal to, those cancel, 3x. And And now it looks like the other stuff. What do I do to get rid of the 3? Divide by 3. Anybody know what 105 divided by 3 is?
30.
35.
So trippy. Kate is like the smartest person I know.
What about the next one? I wish they were numbered. X divided by 0.2 is equal to 10. What do I need to get rid of?
0.2
Okay, is the 0.2 being divided or multiplied?
multiplied.
I'm asking, what does the equation say? I guess that's better.
Divided.
It's being divided. So to get rid of it, I
Multiply.
multiply, yes. When you multiply by a decimal, does the number get bigger or smaller? Smaller. So x is equal to 2. All right. Last two. 15 over 2 times x. So there's a couple ways to do this one. What does it mean? What does this mean? If it's 15 over 2 and then like sitting right beside the x, what operation are we doing? We're multiplying, right? So I should do what? What's the opposite of multiplication? Division. So you can go divide by 15 over 2. Divide by 15 over 2. This is the way I wouldn't do it, but this is one way to do it. So how do you divide fractions? You flip the second one. So I'm going to get, so all that cancels and I get x is equal to 3 times 2 over 15, which is 6 over 15, which is? Nice. Okay. I wouldn't do it that way. The way I would recommend is this. 15 over 2 times x is the same as this. 15x over 2 is equal to 3. This variable, if it's floating in the middle, all right, is like x over 1. And how do you multiply fractions? Like top times top, right? So the x can just sit with that, the numerator. So then it's 15x over 2. So what would you do here? How would you get rid of the 2? Times by 2. Both sides by 2. So times 2. Oh, Magnus. And I get 15x is equal to 6. And then what would be your next step? Divide it by 15. And there's your answer, which reduces to 2 over 5. Okay? So maybe at the very top, I'll go back. Up here where we say remember this and this, remember this. A over B with an x there is the same as ax over b. That x goes to the numerator. Yep. You can do decimals. I guess that would be the other way to do it. If you wanted to do decimals, look, there's going to be, the problem is there will be a point where you can't do decimals. Hello, Miss Wallace. Okay, last one. Look at this one. What's the problem with this one? The variable's on the bottom. You still follow the rules. First of all, we do not want the variable in the denominator. We want to get it out of there. So how do I, in this equation, it says 10 over x, which means 10, what? Multiplied, divided by, or subtracted? Divided by. So what's the opposite of division? Multiplication. So you multiply both sides by x. So you get 10 is equal to 4x. You never want your variable in the denominator. Guys, stop. Now you get 10 is equal to 4x. What do I do to get rid of the 4? Divide. What's 10 over 4?
10 over 4 is
Now.
2.5, yes.
5 over 2. All right. 10 over 4, divide them both by 2.
Oh, yeah.
Stop the decimals.
Decimals are better, though. Just like